Hey guys, welcome back to Consistent Code. So today's problem of the day is print leaf nodes from pre-order traversal of binary search tree. So basically you have been given the pre-order traversal of a binary search tree and we just need to find all the leaf nodes of that tree. And we have to do this without building the tree. So how can we do this? So let's just see how we can do this. Suppose we are having a tree. Let's say let's first consider some cases. Okay, so let's say the first case is when we are having only one node, uh, or we can say only root node. Okay, suppose this is my tree having only one node, so this is also my leaf node, so this is also my leaf node. Okay, this is one case. I want you to consider next case when you see like maybe you are having some tree like this 3 2 and let's say 1. So in this tree we are having only one leaf node. This is this one. Okay, so how can we identify that this is my leaf node? Let's say in this previous case when we are having only one node, then our pre-order traversal was like only this one. So we know that there's only one node, then it is my leaf node and the root node simultaneously. Now in this case my pre-order traversal would be like 3 then 2 and then 1. So in this case my 1 is the only leaf node I have. So from this what you can observe, the observation from these two cases is that the last element of my pre-order traversal is always a leaf node, right? You can just check it for any case. So this is one of the observation. Now let's take some more observations so that we can solve this problem. Now let's consider some other tree, like let's say we are having 3, then 2, then let's say this is 1, and say this is 4, and this is 5, and let's say this is let's say this is 6, and this is 5, and this is 7. So now the leaf nodes are 1, 5, and 7, and the pre-order traversal for this tree would be, let's see. So the pre-order traversal for this tree would be first we need to just follow this thing, root, then left, and then right. So first is root 3. So first will be 3, then 2, then 1. Then we will go to the right. Then that is 4, then 6, then 5, and then 7. So now this is my pre-order traversal, and now I need to find the number of you can say leaf nodes. So how to do that? So just see one thing, that if I start from the root node, okay, and I move, suppose I'm here, and I can now move to the next element. Okay, first of all, let me just tell you, how can you identify that this node is going to be leaf node in the pre-order traversal? So for example, if we are at this place, so now we can just check if the next element in our pre-order traversal, because in the pre-order traversal, the first we have root, then we have the left child, and then the right child. So since it is a binary search tree, the left child needs to be smaller than the parent. So if the next element, like this is 2, if suppose this is my I, so if error I plus 1 is smaller than my current error I, that means we are having a left child, and that means that we can check for the left child, right? So now I want you to consider make a stack. Okay, I want you to make a stack and push the 3 in the stack when we are having left child or left subtree for a node. Why I am asking you to do that? Because if we are having this 3 and it is having a left child, then obviously this left child will have a leaf node. And how can we identify this is having a leaf node? Let me just tell you. For example, if now you will move on to the next element, this is 2. So now we will again check the next element, that is 1. So we will check if 1 is less than 2. That means this 2 is also having a left child. So we will move on just to push this 2 in our stack and move to the next element. Now we are here. So now we will again check that if we are having left child for 1 also. So we will check the next element and check if 4 is less than 1. So we will get no, 4 is not less than 1, right? So what does that mean? That if the pre-order traversal, we know that first it is root, left and right, and right will be greater than root. Then that means when we meet this condition, that means that the next element is the right of this node, uh, the node above, right? So how now we can say that let's say these are our leaf nodes. So we have obtained our first leaf node because we have obtained this condition that the next element is actually greater than my ith element of array. So 1 becomes my leaf node, right? And when we find a leaf node, we need to remove all the elements that are um, smaller than my next element. So all the elements in the stack which are less than 4, I need to remove them because now I'm done with this part. In this part, I'm having only one leaf node, right? So I've got this one as the leaf node, and I will just remove these two elements, 2 and 3, from my stack. Okay, so now I will just move on to the next element, and I will see that if the next element, that is 6, is less than my 4, so that I can know if 4 is having a left child, but it is not the case. So in this situation, I'm not going to do anything. I'm just going to move to the next place, and now I will just check for 6 if 6 is having left child by checking the next element, that 5, is it less than 6? So yes, 5 is less than 6. That means 6 is having a left child, so I can just push this 6 into my stack. Okay, now I will just move to the next element and see that if the next element of 5 is the left child of 5, so 7 is 7 less than 5, so I get no. That means I have reached a leaf node, that is 5 is a leaf node, right? So I can just push 5 in my leaf node array, and also I can pop all the elements less than 7 out of my stack. So I can just remove the 6. Great. Now I will move and I have to just iterate to this array, and finally I can just push the 7 because as I have previously stated that the last element in the pre-order traversal is always a leaf node, right? So we get these as the leaf nodes. So I hope you got the intuition how we are doing this, but I think it would be more better if I explain it to you once more because maybe you may not have got it clearly. So let me tell you, if I am at a particular node, let's say I am at this 3. So what I am doing, I'm first checking if this 3 is having a left child. How can I do that? I just need, suppose I was here at 3, so I just need to check the next element of pre-order traversal. If this is smaller than this 3, that means it is the left subtree of 3. So I can just say that I need to push this 3 in my stack because this will be used later to compare, right? So similarly, then I can move to the next element. I can check it for right for the first for the left subtree. So 2 is also having a left subtree. I will push it. Then I will move here at 1. So I will check if the next element is smaller. So that is to check if it is having a left child. So I get no, it is not having a left child. Now I need to check if this is having a right child. So for doing that, I need to check. I need to just see that the next element is greater than 1. And but now there are two things here. Okay, for when we are at 1, and if we get the next element, that is you can say ARR I plus 1. If ARR I plus 1 is greater than my current element, okay, this is one thing. So what does that mean? That this ith element, let's say 1, is having a right child if this condition satisfies. But there is one more thing, that if we are having stack, then the top element of stack, it's like 3 and 2. The top element will be the parent of 1, right? So if 1 is having a right child, then it should be smaller than the parent element. So if array of I plus 1 is greater than my stack dot top element, that means that this ith element is not having right child. Instead, it's a leaf node. Okay, it is a leaf node. This condition is for having it that this is a leaf node. Okay, and this condition, the above one, is for right child. So we are only bothered about this leaf node condition. So we can completely ignore whether it is having a right child or not, because what we want is a leaf node, right? So now let's code this so that it becomes more clear to you. All right. So let's code it. So first of all, we need a stack, right? So I can just create a stack. Let's call it S. And now we need to start iterating our pre-order traversal. And since the last element of pre-order traversal is always a leaf node, I am going to just iterate till n minus till before last element, right? And I can push the last element manually after that. So first, what we need to check if it is having a left child. So how are we gonna check that? We can check that using this condition, that if this current element is greater than the next element, that means it is having a left child. So in this case, we can simply push this current element into our stack, because this becomes the root of the next element which we are going to iterate over, and we are gonna need the parent element. That's why we are pushing this. Otherwise, if we want to, if the next element is actually greater than this, then as I have already told you that these two conditions are possible, and we only care about leaf node condition because we want leaf node, right? So we just need to check if the next element is greater than my root element, right? Like if I am at this place at 1, and if even if it was having some right element, so if even if it does have, I just ignore it and I move to the next element. But I am considering if the next element, that is, it should be 4, that is, the root of 1 is 2, so it should be greater than the root, so that I can be sure that 1 is a leaf node. Okay, so that's what we need to do. So I just need to check that the next element should be greater than my top of stack, and also we also need to check that our stack should not be empty, otherwise we will get a segmentation fault, right? So now that we have checked this, if this condition satisfies, that we can be sure that we need to add this element in our answer. So let's also create a vector to store the leaf nodes. So here I can just say that this is a condition for leaf node, that the ith element which we are, the current element is a leaf node. So I can just push this element in my stack, not in the stack, sorry, in the answer. And also now we need to remove all those roots which are smaller than the next element. So I can say while the stack is not empty and the top element of my stack is less than the next element, I want those elements to be popped out, right? And after that, in the end, I can manually push my final element, the last element in the pre-order traversal, into my stack, right? And then I can simply return my answer as a leaf node, right? So now let's try compiling and running the code. And we are getting the correct output. So now let's submit the code. And we have solved this problem successfully, and I hope you liked the explanation. And if you did not, I maybe you did not understood this problem because this is a little bit confusing, so I would like you to rewind the video and rewatch this so you can get understand it better. And if you did understand, then that's awesome. And you can like this video and subscribe to the channel if you like the explanation, and I will see you tomorrow with the next problem of the day.